and welcome to another episode of FooBar. Today we are going to look into one of the most popular event-driven architecture patterns, Popsoft. In the previous video we talked about queues, and before, in the first video of this series, we talked about why and what are event-driven architectures. So if you want to see that, the playlist is linked down below. In today's video, we are going to talk about Popsoft, what it is, what problems it solves, and how you can get started with it on AWS. So this video is part of a longer series of videos in which we talk about event-driven architectures. I mentioned the first two ones, and there are more coming in the future. So stay tuned for that. So let's get started with today's topic. Popsoft Messaging. Publisher, subscriber, messaging. Basically, one part produces the messages and the other one is subscribed to somewhere where they can receive those messages. And before we have the queues, that is one producing the messages and the other one is listening to, is basically one-to-one when there is a queue in the middle. And now we have this concept that is one publisher and many subscribers. Like now, you're watching YouTube, I'm Juan Marcia, I'm publishing a video, and luckily there are many people watching this video. You're subscribed to my channel, I hope, and you're watching. This is the idea. So basically, when I put a video out, you get notified that if you have turned the little bell on, that there is a new video. All of you get notified. And in that way, you're subscribed. It's the same with this pattern. One puts a message somewhere, and the ones that are subscribed to that type of message received a notification, basically receives the message. So basically, this something is an event router that we have in the middle is called a topic. And basically, you're subscribed to a topic, and you receive the message. You're subscribed to a YouTube channel, and you receive the video. And basically the publisher publishes the topic and everybody subscribes to it. And in this way, you can publish messages to thousands of customers, of thousands of subscribers, and it's one too many. You might have heard about something similar, another type of event router, that is the event bus. In this case, we have a similar thing. We have somebody's putting a message into the whatever event router in this case, and then many are receiving, and this is achieved with an event bus. This is a different pattern, and we will look at that when we talk about event buses. And if you want to get started, I have a whole thing with EventBridge, so you can go and check it out. But for now, let's continue with Popsoft. So we said that is one to many, and and when we look at AWS solutions for that, we have the obvious choice that is the Amazon Simple Notification Service, Amazon SNS. And basically, we use a lot SQS in the previous video. In this video, we are going to use SNS. Also, we have EventBridge that can work as a Popsoft, I told you before. And we also have Amazon MQ, that is another solution. And one other solution is AWS IoT. And this is a solution that we use, for example, in Serverless Expresso. So if you have not watched that video where we talk about how to build a solution with IoT message broker that basically sits in the middle, allows you to publish one-to-many again, and it allows you to do MQTT, and WebSockets and things like that, you can go and check it out. But in this video, we are going to talk about AWS SNS. So basically, SNS is a service that means one-to-many. One part sends a message to SNS and many can receive it. And when I mean many, it can be a Lambda function, it can be a queue, it can be another type of service, it can be an endpoint, it can be an email. We use that also for sending notifications of alarms. For example, in AWS, you might have seen it. When you have an alarm, it tells you, can you tell me where to send this alarm? And that's using SNS. Also, you can use it for push notifications, you can send text messages. So basically, there is these two types of receivers of these messages that can be either applications, like other AWS services or systems like HTTP or Lambda, or it can be persons with email, SMS, or push notifications. I want to focus more on the applications because I want to demo it, and for this type of event-driven applications, this is our core. So basically, these notifications are pushed to subscribers. This means that messages are pushed directly to the targets as soon as the messages are received. So if the messages are coming too fast, then the targets can get bombarded. So this is important to have in mind, and we will see some examples on how to kind of not overload our targets in a second. Also, messages don't stay in the topic for too long. In the queues, we saw that basically the target is pulling out the messages. So when the Lambda function in this case was ready, was taking one message. And in this case, basically, it's just receiving them all. One cool thing about these topics is that you can have filtering. So this is one solution to not overload your targets. So you might have targets that are interested in different things. So you can have filters in the messages, and basically those targets can subscribe to the different filters. So for example, you can have country based filtering. You can do the filtering whatever you like. We will see an example in a moment. And then only the subscribers that are subscribed to that particular country will receive the messages that are related to them, so they don't have to receive all the messages. So the filtering is applied and they only receive those messages. Also, because SNS has such a big throughput, and this is one big difference, for example, with EventBridge, it has such a big throughput that it can overload the targets. One typical pattern that you see is that you have SNS plus SQS, meaning that you have the advantage of the one-to-many and also the advantage of having this buffer in front of the target so you don't overload them. I will show you an example of this as well. So basically now the publisher can send a lot of messages, the SNS will send them to different queues, and then the queues will basically send them to the subscribers in the right load that they can take. Well, basically subscribers will pull from the queue. Another typical question that some people ask when I talk about SNS and I talk event-driven architectures is, what is the difference between EventBridge and SNS? And that's something that maybe it's a topic for a different video, but I want to leave a couple of thoughts out there. SNS has a huge throughput, so very low latency and very high fan out. So you can send to thousands of millions of endpoints, and EventBridge is not like that. So if you need something like this, SNS is your answer. Also, SNS has this filtering mechanism that you can send and do this filtering, and you can send to persons like email, SMS, and push notifications. EventBridge has a lower throughput, but it has way more flexibility on the components that can send messages. It can be a SaaS application, it can be many AWS services, it can be custom applications. It has the idea of custom buses. It has many things built in with the rules that you can do a lot of customization and filtering in there and intelligence in there. And it has a lot of things for events and a lot of functionalities that SNS doesn't have. So it depends on what you want to build and what is the type of application you want to build. You might pick one or the other, or you can pick both in different situations. So have that in mind. So now let's go to the code and see some examples. I want to show you 3 examples. The first one is, let's build a simple SNS and a Lambda function and see how it works. Then we will add some filtering in there and we'll see how it works and how it's built. And then we want to create this SNS SQS pattern and see how that works. Everything, as always, is built with infrastructure as code, and the tool of choice is AWS CDK, and all the code is available in GitHub for you. So let's go to the code and check that out. So for this demo, I have already created all the code because it's easier and I can show it to you. It's an CDK app, nothing else. You will find this exact app in GitHub, so you can trace it. But basically it has one bin folder here that is basically building 3 stacks. And each stack is a little different than the other, but they are all more or less the same. And let's start with the simplest of all, that is the SNS stack. So let's open this a little bit bigger and we can see here what we have. Basically we have Lambda function that sends a message to an SNS, and then that SNS is triggering a Lambda function. So something very simple, and this Lambda function is triggered, the first one, with a Lambda URL. If you don't know what Lambda URLs, check that video out. It's explaining everything. So basically, we first create a topic, and to create a topic in CDK is very simple. Just give display name, and then you're there. Or I don't think this is an optional one. You might not even need that. This is the Lambda function that puts a message into SNS. You can see that I giving the topic ARN. So this is the topic here, and giving the ARN as an environmental variable. And this function is triggered by a function URL, basically an HTTP endpoint that we can test and send and try it out. Then I have these permissions. So basically now my function can publish messages in that topic. So let's check that function first, and you will find the code in here. It's called sender, and this is the one. So what this is doing is just putting a message into this topic. So basically using the AWS SDK and putting a message that basically when we are sending this message into this topic, and then I'm publishing that. And then that message goes into the topic and triggers a second Lambda function that is here. And you can see that this Lambda function is consuming the message, and it has a subscription to that topic. So SNS add subscription, new Lambda subscriber, here it is. And that's it. You will see it trigger. So we can deploy this and check it out. CDK deploy, let's deploy them all. So we can get all the URLs, and we don't need to deploy this all the time. I have my URLs here. Let's open this app in Thunder Client. If you don't know what Thunder Client is, you should go and watch my video about extensions for your Visual Studio Code. So you know what these are. I will use many here as always. I'll leave you the link in the description box. And basically this is, we are executing the first Lambda. When I put this Lambda URL here, I don't think it should return anything. Result, well, let's see. And then we can check the logs of what is going on. So let's open the serverless console, and I might need to, let's see if these ones are still valid. Might need to add here a new one. To add the stack that we are going to check, that is the CDK stack. So let's add that one. And we will check the function that is sending, and it's sending. This is the params. You can see here it's sending with this request ID and this message ID, and this is the text. Let's see the consumer function. It got triggered, so that's good. This is working, and you can see that this is the event. The consumer function I didn't show it to you, but it's basically just printing the event. That's why I didn't show it. And this is the event that it got. And here is the message. The message was sent at this time, blah, blah, blah. So that's good. This is working. First step done. So let's go and check the next level. So now we want to add filters. So it's the same idea. We have a topic. We have a function that gets triggered with a Lambda URL, or the function URL that is putting a message into this topic. Until there, we are good. We are the same. And then we also give permissions to that function. And then we have free functions. In this case, I think 2 will be enough, but I put free. Free functions. One is that is called consumer red, consumer green, and consumer blue. And here we have a subscription for the red. And you can see here that I added a filter policy. So basically, if the color is red, then it's going to send it here. So, well, the color should be rojo, that is red in Spanish. And if not, then all of the others will receive the messages. So if the color is red, free lambda should trigger. If the color is blue, 2 lambdas will trigger. If the color is green, 2 lambdas will trigger. I was planning to do more detailed filtering, but well, whatever. So we can check that out. So again, I already deployed this thing, so we should have the URL somewhere here. Let's see if my terminal helps me here. Nope, it doesn't. It's a little crazy. So I will find the URLs and I will be back. So good, I have the URL. So let's go and check what the sender function does, and then we can send a message. So the sender one, now it's a little different because we want to get that color into our topic. So if you remember, there's a Lambda function that gets triggered with an URL that puts a message in the topic, and then the topic will send that message to 3 Lambda functions, but one has a filter enabled. So we have the code for the sender, and basically the sender is checking the query string parameters for a variable called color. And there we will put the color, and that will be the message. The color is green. And then basically we will put that message, and it doesn't matter what the message is, but the important thing here is this message attributes. And here is where the filtering happens. So you can see here that the color is here, and if you check the code, there is this color here. So this needs to match, be the same name. Oh. And then we have to find what is the data type, that is a string, and the value, that is the color. So here is this value that is coming here. So basically we will check for the color variable, and if it has the name rojo, then we'll trigger this Lambda function. So let's check it out. So let's do this, and then let's do color blue. And this should trigger 3 Lambda functions. No, 2, sorry, the green and the blue, because I have not added filtering. So let's go and check serverless console. Let's see if these ones are configured. Green, trigger, a few seconds ago, and we can see the color is blue. Blue is triggered a few seconds ago, and we can see the color is blue. And red is not triggered. So that's good. Let's go and put the color rojo, because that's the word that we are filtering for. So now the 3 lambdas should be triggered, the ones without the filter and the one with the filter. So let's check the red one, and let's refresh this, and let's pray for the gods of the demos that it works, and it does, and that's good. Now we can see here the color is rojo, and we can see the same in this. I'm a little clumsy, funny today, sorry for that, but recording too many videos. And here we can say the color is rojo, and we can see that in here as well, the color is rojo. So that's good. Second demo, then. Let's check the third demo now. And this one is a little bit different. I told you about the SNS plus SQS, and this is what I want to show you. So let's look at that. So we have the topic as we had before. We also have now a queue. This is like the queue that we defined in the previous episode. And now we have a Lambda function that sends a message into the topic. So that has not changed. This is also triggered by that Lambda function URL. And the function is publishing messages to the topic and getting permissions for that. Until that, we are good. Now, you can see here that the one subscribing to the topic is not a Lambda function, but is the queue. And this is a change that we want to make. The topic, we add a subscription, and is a queue. And then we have the Lambda function here that is getting triggered by a queue. And here you can decide how big the batch size it is. You can decide all those things, and you are going to pull the messages as much as you need. So here we are building this, basically this fan-out approach with the queue and the Popsoft. So this is super handy, and you see it's pretty straightforward to make. So we can test that. I will grab the URL and we can check all the code. So now I have the URL, but before getting in there, let's check the code, and we can see that the sender is this same sender as before. We could add filters here, and we can have different queues subscribed to different topics, but for this simplicity, I just have one queue subscribed here, but we could have the same filtering for the queues, and that's totally fine. But basically, this is every time there is a request in the Lambda function, is putting a message to SNS. SNS is then sending the messages to the queue. Then the consumer is here, and the consumer is the same consumer that is just printing the messages. So nothing has changed. So let's send that. And we can see in the serverless console, in here, the sender has been triggered and it sends a message. That's what it does. And the consumer is triggered and has received the message. So here the message is hiding in the body here, but it's there. So we can copy this to clipboard and we can see it in more detail. So let's do this. And here we can see that the body of this message has the message. So where it is here, message, el mensaje was sent at this time. So this is the message that we put. Because of the queue and the Popsoft thing, it gets wrapped twice, and that's kind of the pain. You need to unwrap it in order to do something with that, but well, it's there and it's quite generic where you can find it, so it's not that impossible. And that's the video for me today. I hope you like this content. I want to show you what you can do with Popsoft. If you want to see more about Event Bridge, as I said, you can check the playlist. I have also talked about IoT in the Serverless Espresso interview with James Beswick. I have all the links for the IDA in the description box. And if you have any questions or patterns or things you would like to see about event-driven applications, please just let me know, because this series is in progress and I want to make content that you want to watch. And I see you in the next episode of FooBar. Ciao, ciao!